Okay guys, here's the page 3 or the third side of the Unit 5 Similarity Review Packet. Let's start with 10. It says solve for the value of the variables in each right triangle. So x and y are on the outside of the triangle. All of the numbers and values are on the outside of the triangle. There's nothing on the inside. That lets us know that it's going to be boomerang. In B, y is on the inside. That lets us know we're using roller coaster. But here, there's nothing on that inside altitude. That's what we call that line there. It's the altitude. So if I want to capture y, sometimes it's easier to look at it like this, because this is how we're used to seeing it, right? So if I want to capture the y, I'm going to go all the way across the one with two parts. I'm going to capture the y, and then I go back only to that to the end of the 9 or to the 1, right, to that altitude. So if I'm going to write that proportion, so the first thing I did is I went across this whole side here that had a value of 10. Then I went across the y, then I went back across the y, and then I went across just the 9. So if I cross multiply, I get y squared equals 90, and if I take the square root of both sides, I get the square root of 90. Now, if you feel comfortable, you can simplify this. This is the same as 3 root 10, but if you were to leave your answer just like that, or if you were to leave it as a decimal rounded to a couple places, that would be fine as well. So now let's do x. X is very similar. I'm going to grab another color if I can find it. So let's do x. I'm going to flip it again because I think when you look at it like this, it's more like what we're used to seeing. So if I want to get the x, I'm going to go across the whole bottom. I'm going to capture the x and go back just the 1 because I went to the altitude, that line. So what did we do first for the green? We went across the whole bottom. That was 10. I went down the x, back up the x, over 1, and if I cross multiply, I get x squared equals 10, and we can leave this like this. And if you were to turn it into a decimal, it would be something like 3 point something something. Okay, B. Well, for y, inside, and so to capture the y, I'm going to use roller coaster. Okay, so if I do that, I went over 2, up y. Ooh, sorry guys. I went over 2, up y, back down the y, over 6. If I cross multiply for that, I'm going to get y squared equals 12. So if I take the square root of both sides, I get the square root of 12. If you wanted to simplify it, you would get 2 root 3. Or you could leave it as a decimal. It would also be 3 point something. If I want to solve for x, this is my boomerang because I have to go on the outside, right? So I'm going to go across the whole bottom. I'm going to capture the x, and I'm going to go back just to the altitude. So the whole bottom was 8, down the x, back the x, down the 6. Remember, we're just going to the altitude. So if I cross multiply, I get x squared equals 48. So you could leave this as the square root of 48. Or if you wanted to simplify that, this would also be equal to 4 root 3. Or if you did it as a decimal, I want to say it would be a little less than 7, so 6.9 or something like that. Okay, number 11 says the shadow of a flagpole is CE. CE is 80 feet. Okay. If the shadow of a 12-foot street lamp is 30 feet, how tall is the flagpole? Well, notice we have two triangles. Here's triangle 1. Okay. Here's triangle 2. No, they're kind of overlapping there. So what I'm going to do is I'm going to do the height over the length of the blue equals the height over the length of the green. Now there's other ways you could have set it up. You could have done height over height equals length over length. But there's only one answer that'll work. So when I cross multiply, I get 30x equals 12 times 80. Well, let me grab my calculator. 12 times 80 is 960. I'm going to divide both sides by 30. And I get 32. So that means that the flagpole's height is going to be 32 feet. That's this height right here. Okay, now let's do a couple of proofs. We want to prove that these two triangles are similar. Well, we know we have to use SAS, and this is why. I have 2 sides marked here. I have 2 sides marked in this triangle. So my only options with S's are SAS and SSS, but since I only have 2 sets of sides, it has to be SAS, which means I need an included means directly in between. So here's the angle directly in between those 2 sides. Here's the angle directly in between those 2 sides. And we know that those angles are congruent. And I'm going to write this really quick. CFB congruent to angle GFH. I had to use 3 letters because angle F could be any of these angles here. We want to be very specific. And those are congruent because of the vertical angles theorem. That's why those angles are congruent. Well, now let's test to make sure the sides are proportional, which means they reduce to the same ratio, the same fraction. So I have 15 and 18. Here I have 25 and 30. We're lining up the 2 smaller ones together and the 2 larger ones together. And when I simplify this, I divide by 5 and I get 3. I divide by 5, I get 5. Divide by 6, I get 3. Divide by 6, I get 5. They both simplify down to 3/5. So I can say, okay, the side that was 15, BF, over the side that was 25, GF, is equal to the relationship between the side that was 18, CF, over the side that was 30, HF. And both of those simplify down to a ratio of 3/5. Now, from the picture, remember? So I'm going to call this given. Now, if you're in a different teacher's class, they might have done this step a little bit differently, and that's okay, but just make sure you're doing it the way your teacher showed you to. They're going to be slightly different just because some people have different preferences for how they set up this proof. Okay, last step. Now I have that one set of angles is congruent. I have 2 sets of sides that are proportional. Okay, so I have my S, my A, and my S. So now I can say that the 2 triangles are similar by S, A, S similarity. So side included angle side, side included angle side. Okay, well, let's do number 13 now. Oopsie, sorry guys. Well, notice this angle goes with 86. This angle is also 86. There's a pair of angles. We know that these are vertical angles, so they're going to be the same. I already have 2 sets of angles for each that are the same. That means we're going to use AA similarity. So my first step would be saying angle S is congruent to angle F. How did I know that? That was given to me. We were told that they were both 86 degrees. Now I'm going to say the measure of angle, just angle GEF is congruent to angle RES. Those are vertical angles. We know that they're going to be the same because of the vertical angles theorem. Well, take a look. I have a pair of angles that are congruent, another pair of angles that are congruent. So now I can say that my 2 triangles are similar because of AA similarity. Okay, let's look down here really fast. It says if these 2 triangles are similar, explain why these 2 lines here are parallel. So why are those parallel? Let's take a look. Notice that the P's line up, the Q and the S lines up. So these have to be the same. The R and the T line up. These need to be the same. Well, angle PTS, this thing here, and this angle here are corresponding angles. Because my corresponding angles are the same, it means my lines have to be parallel. So I would just say, because corresponding angles are congruent, the converse of the corresponding angles postulate tells us the 2 lines, oopsies, I forgot my I, the 2 lines, QR, segment QR, and segment ST must be parallel. And really, this should have segments there and there. That was our mistake. Okay, that's the end of video 3. I'll get started on video 4 soon.